Hello and welcome to Train Signal. You are watching Linux Links and System Files. Over the last several lessons, we've learned about how Linux interacts with hardware, how the system boots, partitions, file systems, and a slew of other system details. But that all shouldn't overshadow the importance of understanding how and where to find your files. Now, you've probably spent many years in Windows learning its file system and directory structure, and unfortunately, much of it isn't going to apply to Linux. However, what that knowledge does is makes it easier for you to understand the importance of a standardized directory structure. So in this lesson, we'll begin with a look at the two types of links in Linux. Then we'll take a look at the system files and their locations. Finally, we'll review the tools available to help you search and locate files and directories. Let's start off first with links. Windows users will be familiar with the concept of shortcuts, and these are pointers to a target file or location. In Linux, these shortcuts are called links, and they're used for many purposes. There are two types of links, hard and soft or symbolic. Hard links are produced by creating two directory entries that point to the same file or inode. In order to delete the file, both directory entries or files must be deleted. Another thing to note about hard links is that they must exist on the same file system. In other words, you can't create a hard link from root to home if they aren't on the same partition. Symbolic links create a separate file whose contents point to the link to file. Since a symbolic link is a file containing file names, they can point across file systems, and for this reason, they're more common than hard links. When you use the ls-l command, it will show a link to file, and we'll take a look at that in a moment. On the next slide, we'll take a look at the command used to create links. The ln command is used to create links. The syntax is ln space options space source space link, where the source is the original file and link is the name of the link that you want to create. The options for ln are -f or ~force, which causes ln to remove any existing links or files that have the target link name. -i or ~interactive does the same thing, but it also queries you before replacing any files and links. -d, -F, or ~directory allows root to attempt to create hard links to directories. And I say attempt because this isn't normally supported on most file systems. Since the ln command creates hard links by default, -s or symbolic is used to create a symbolic link. Let's try this out. Let's move over and open a terminal window. From Applications, click on System Tools, then Terminal. Okay, the first thing that we're going to do is to create a dummy file using the touch command that we reviewed previously. But first, let's switch over to our Documents directory, since I am a stickler for organization. So we'll type in cd space documents. Now to create our dummy file, we'll type in touch space, and I'm going to call it linktest, linktest.txt, and hit enter. A quick ls should reveal that our file has been created, which it has. Okay, now to create the symbolic link, let's type in ln space -s for symbolic, space name of source file, which is linktest.txt, and then the name of the link that we want to create, and I'll call that new file.txt, and hit enter. Now if we type in ls space -l for the long listing, hit enter, we should see that we have now an L in front of the file, which indicates that we have a link, and then the file pointer at the end says that our new file link is pointing to our existing file link text. Okay, let's head back to our presentation. If you recall from our Linux file systems lesson, the E2 FSCK file system check program is usually a link to FSCK. So that's one example of how to use a symbolic link. Let's move on and talk about Linux system files. We know that Linux is a derivative of Unix, but in the beginning, that transition wasn't quite so smooth. There were few standards and lots of disagreement. This eventually led to the development of File System Standard, or FSS-TND, back in 1994. It standardized programs that sit in bin and user bin, and it also said that executables should reside in etc. And it removed changeable files, or transient files, from user, enabling read-only mounting, which is a pretty good security measure. We'll talk more about these file locations in a moment, but for now just bear with me. They soon found that the limits of File System Standard were being reached. That led to the development of File System Hierarchy Standard, or FHS, which was developed around 1995. A distinction was made between shareable files and unshareable, static and variable files, program executables, and user files. The table below represents how FHS sees important directories. It views static files as belonging in user and opt, and unshareable in etc and boot. Variable files, or files that change fairly often, are in home or possibly var mail. And unshareable variable files are in var run and var lock. Now let's take a look at more important directories and their contents. The next couple slides outline the most common FHS directories. For those of you pursuing certification, it's critical that you understand this structure and the contents of the directories. The first is represented by a / and is referred to as root file system or root directory, and all directories branch off of root. I made the early mistake of confusing this directory with /root, which we'll get to in just a moment. Boot contains static and unshareable files related to booting the computer. Bin has critical executable files, things like the most common user commands like ls, cp, or mv. SBin is very similar to bin, but it contains programs run by the administrator, things like fdisk. And lib contains program libraries. I'm going to hit Control-C to stop. Actually, it stopped for me. As you can see, Yum is located all over the place essentially. Now I should note here again that Yum uses its own database, so you may not get the results that you expect if that database hasn't been updated recently with UpdateDB. Okay, now let's try type. Again, type will show you how a command is interpreted. So let's type in type space ls and hit enter. And this says that ls is alias to the command ls:color equals auto. Now let's try out find. Find is usually the best approach for finding those hard to find files, and it's the option that I use most often. So let's type in find space -name. We're going to use the name parameter because we know the file name that we want to find. Then we'll type in a file that we know is on the system. I'm going to type in user-manual.doc and hit enter. That file is located under the Documents directory. You'll probably want to spend some more time practicing and trying out your search commands on your own. And that concludes our lesson on Linux links and system files. We'll review what we've learned on the next slide. As an administrator, you'll find yourself really relying on the information that we've learned in this lesson. To recap, we covered links, including hard and symbolic links. Then we talked about Linux system files and their locations. And we wrapped up with the different tools at your disposal that can help you search for files and programs. Thanks for watching, and I'll see you in the next lesson.